Welcome back to the channel. Today, we're diving deep into a cosmic phantom. I'm talking about an object that might not even exist, but if it does, it could hold the key to fixing one of the biggest problems in all of physics. Just let that sink in for a second. We've always thought of black holes as the final boss, right? The universe's ultimate monsters. But what if that's not the whole story? What if there's something else out there? Something that looks just like a black hole's identical twin, but underneath, it's something totally different. And honestly, a whole lot weirder. You know, for decades, black holes have been the go-to answer for what happens when a giant star dies. But they come with this massive theoretical headache. So, what if that's not the only way the story can end? What if there's a cosmic contender we've been missing this whole time? All right, let's get into it. The story you probably know goes something like this. A really, really massive star burns through all its fuel. Its own gravity takes over, and bam, a supernova explosion. The core that's left behind collapses. And if it's heavy enough, gravity just keeps crushing it down into what we call a black hole. And this right here is the fatal flaw. See, our theories tell us that deep inside every black hole is a singularity. That's a point of infinite density where all the laws of physics just completely fall apart. It's where general relativity and quantum mechanics, our two best rulebooks for the universe, just stop making sense. For a physicist, that's like getting a divide by zero error in the source code of reality. It's a huge red flag. So to try and fix this singularity problem, a couple of physicists, Pavel Mazur and Emil Matola, came up with a really radical idea back in 2001. They basically asked, hey, what if the collapse just stops? What if it stops before it can form a singularity? And what if, instead, it creates something totally new? And that's where the Gravastar comes in. Okay, so this is where things get really weird and interesting. Instead of matter collapsing forever into an infinitely tiny point, imagine it getting squeezed so hard that it actually transforms into a bubble of pure energy. And this energy bubble, it pushes back. It pushes back with an incredible force, fighting gravity to a dead stop. The collapse just halts. So what do you get from this cosmic standoff? What kind of object is actually created? Well, the result is this wild, layered structure. It sounds like something straight out of science fiction, but it's actually grounded in some pretty serious physics. It's called a gravastar, which is short for gravitational vacuum star. Think of it like a giant cosmic soap bubble. Seriously. But instead of soap and water, its skin is made of some seriously exotic matter, and the inside is an air. It's a super pressurized kind of pure vacuum energy. And this three-layer structure is the key to how it all works. You've got the core, which is this pure vacuum energy that actually has negative pressure. It pushes outward, kind of like the dark energy that's expanding our universe. Then, that outward push is perfectly balanced by this incredibly thin but super dense shell of exotic matter. Together, they create a stable object that can hold itself up against gravity's crushing force, and poof, no singularity needed. And the way this shell gets made, it's just an event of unimaginable violence. I mean, picture it. You have the crushing force of the star collapsing inward, and it slams into the titanic outward pressure of that energy bubble. Matter gets trapped right in between, like a hammer striking an anvil, forging a completely new kind of material at the very edge of what physics allows. That shell isn't just strong, it's extreme in literally every single way. It's thought to be the coldest place in the entire universe. We're talking just a billionth of a degree above absolute zero. And the reason it's so cold? It's not made of normal atoms buzzing around. Nope. It's a perfectly smooth membrane of what physicists call exotic matter, a state so stable and so tightly bound that it's basically frozen solid. And if you think that's strange, the inside is even weirder. It's a perfect vacuum, totally empty, but it's not nothing in the way we usually think of it. It's more like a super condensed nothingness. It's the raw, fundamental energy of empty space itself, all compressed down to its absolute limit. And this is what's generating that massive outward push, holding the whole thing together. Okay. So if these incredible objects could exist, why haven't we ever found one, right? Why is every supermassive thing we point our telescopes at labeled a black hole. Well, it turns out a gravastar is the perfect cosmic imposter. From the outside, you can't tell them apart. A gravastar and a black hole are basically indistinguishable. As you can see here, they both bend spacetime in a huge way. They both slurp up matter into a glowing accretion disk, and yep, they both trap light, making them look perfectly black. They're cosmic twins, which makes spotting the difference a massive, massive challenge.
So that leads to the billion-dollar question, doesn't it? If they look the same and they act the same, how on earth could we ever know the difference? Are we just stuck, never knowing if we're looking at a real black hole or its freaky twin? Well, luckily, scientists have one last trick up their sleeve.
The one key difference, the smoking gun. It all comes down to one thing, a surface. See, a black hole has an event horizon. That's a point of no return, not a physical thing. A gravastar, though, has a hard physical shell. You can't touch an event horizon, but you could, in theory, smash right into a gravastar shell. And that difference, it becomes absolutely critical when two of them collide.
And here it is. This is the clue we've been hunting for. When two black holes merge, it's clean. The signal we get in gravitational waves is like a deep, single thump that fades away really fast. But if two gravastars were to collide, their physical shells would actually smash together and vibrate. And that should produce these little gravitational echoes after the main crash, kind of like hitting a cosmic gong that keeps ringing out.
Now, scientists are on the lookout for these exact echoes using observatories like LIGO. They've gone back and looked at the signals from real mergers, like that famous first detection, GW 150914. And the research on that one was pretty clear. The signal was a perfect match for two black holes merging, and they concluded it couldn't be explained by a colliding gravastar. But the case isn't closed just yet. While that analysis, and others, point pretty strongly toward black holes, these echoes would be incredibly faint. It's like trying to hear a pin drop in the middle of a hurricane. A lot of scientists argue that our current technology just isn't sensitive enough to say for sure that gravastars are ruled out. We need better ears, so to speak, to listen through all that cosmic noise. So yeah, the verdict is still out. Okay, so let's boil all this down to the three big takeaways. First, the whole idea of a singularity at the heart of a black hole is a huge problem for physics, and that's what got scientists looking for other options. Second, gravastars are this wild potential fix, swapping the singularity for a stable shell around a core of repulsive vacuum energy. And third, even though they look identical from the outside, the one way we might be able to tell them apart is by listening for the echoes in gravitational waves when they crash into each other. So that leaves us with this really cool question, right? Are gravastars a brilliant solution to one of physics' biggest headaches? Or are they just a fascinating idea that's ultimately destined for the discard pile? I mean, it neatly solves the singularity problem, but it brings in its own set of seriously weird concepts. For now, it's just a compelling, totally unproven theory. Only time and much more powerful telescopes and observatories will give us the answer. And that's a wrap on Gravastars. Hey, thanks so much for sticking around. If you've got any thoughts or questions, definitely drop them in the comments below. And make sure you stay tuned for the next mystery we try to unravel.